So you ask for the capital I is for interactive. Time is 30 minutes, as usual, number of nodes. All right, for the workshop here, you would add the queue name being in the reservation queue. And you probably will need to add your project name as well, -A, comp perf workshop, right? But the main idea here is that you're not giving a job script, and what happens is this goes into the queue, and when it would have run, what happens is you get a shell. You get a shell prompt. So where is that shell prompt? It's not on the login node. It's actually on what's called a mom node, which is a kind of like a service node set up to launch jobs from. And in fact, that's when you submit a regular job with a script, the script runs on a mom node. This is Cray terminology. When you get that shell prompt, just realize it's not on the same login node that you were. And but otherwise it's a normal shell prompt. And you could type things exactly the way they appear in your job script and run them interactively. So, for example, you could type app run on 64 nodes and all these other options and just run it. Well, if you already have a job script and you're trying to figure out how to get it to work, you could actually just run it from the shell prompt there, and that would work fine too, unless it's doing something funny. But 9 times out of 10, that should be just fine. Just be aware that if your job script has any Cobalt options at the top of it, if you're using the #Cobalt comment styles at the top to select, for example, number of nodes and things like that, those aren't processed when you just run it this way, right? You've already started your job. So if you don't know what I'm talking about, you haven't used that, and you're okay. Don't worry about it. So if you exit this shell, then your job goes away. That's exactly the same thing that happens when you have your shell script that you submitted, and you get to the end of the shell script, then your job dies, right? So don't exit the shell, but what happens is you can, as long as that shell is alive, your nodes are allocated and you can repeatedly run things. So if you do your app run, or if you run your job script and it didn't work right, you can tweak something in your input file, or you can even, go and recompile your code, make a little change quick, and then just run it again. You don't need to wait in the queue again because your job is still active. So this is a big time saver when you're trying to figure things out. So suppose you had submitted this interactive job for 30 minutes, like I described here. What happens when the 30 minutes is up? Well, your job does go away, but the shell doesn't go away. And unfortunately, there's no easy way to print out a message to say, hey, your job went away. So you kind of have to be aware of that yourself. And so what would happen if your job went away and you tried to do an app run? You'll get some weird error message saying the app run failed. It may say something like the resource is unavailable or something like that. So what you should do if you're wondering, well, why all of a sudden did the program won't even start? Forget about your debugging issue. Just do a QStat on your Cobalt job ID, as it suggests at the bottom here. And if it spits out information about your job, then your job still exists, right? But if the output is blank, then your job is gone away. And what you need to do is to, exit your shell and then start a new interactive job. So why do we not make the interactive shell go away? Well, if you're editing some source code or something like that, you wouldn't want it to just get nuked right then, right? So it's the lesser of the two evils. You have the opportunity to save anything that you're working on before you exit, but you can't use the nodes beyond the allocated time. So I strongly encourage using interactive mode when you are getting your stuff running for the first time. Okay, so suppose your program's running now. It's running in parallel, and it dies. Well, if you have 1,000, 2,000, 3,000 nodes worth of processes running, right? They all can't dump binary core files like a regular, Linux system, right? It would actually, it would be terabytes of data. It would bring the file system to its knees, and it would be data that would be kind of useless, actually. So there's a way for, there's a program called STAT, and what STAT, it's an acronym for Stack Trace Analysis Tool. And what STAT does is, if it's invoked, it generates what's called a merged stack backtrace. So it's sort of like if you examined all of the backtraces on all of your MPI ranks and looked at how many were in the same place and only recorded that once, right, and kept a count that 16 of them were in this spot in the code and 1,000 of them were in this spot of the code, right? And then it does that merging of comparing them all in parallel. And a Cray feature called ATP, Abnormal Termination Processing, is an automatic way to invoke STAT when your program dies abnormally. Okay, so there's really two things involved here. You don't really need to know the details, but I'm just trying to explain the terminology. So essentially, if you turn this on, when you run your program and it dies, you will get a file, a backtrace file, that will let you figure out what is going on. So how do you do that? Before you link your program, you should just check that the module called ATP is loaded. It should be loaded by default. So you really shouldn't have to do anything, but you can do a module, a module list and see if it's currently loaded. Just look for ATP. If you're using either the Cray or the Intel compilers, which Intel will be by default, then you should be set. So it's just something to check. Then inside of your job script, just set the environment variable ATP enabled equals 1 before you do your app run. Whatever app run you're going to do the same thing, but just set this variable before the app run, and that enables this functionality when your program crashes. So you'll get a file if it crashes, and the way you look at the file is using a tool called StatView. To get StatView into your path, you probably need to do a module load stat. Okay, so this is a really simple example where I had a program that I just made it core dump and dumped the file. And what this is showing, it's hard for me to see the colors here, is that your main program, the system called a main routine, which called another routine, which called, actually we only get to main at the third level here. So main here called a function called foo, which then called sleep, which then I either killed the program manually or I had it abort after the sleep. So this backtrace is pretty trivial, right? But if you had, an if statement where half of them went one way and half of them went the other, this thing would look like a tree, right? And then you'd be able to see that, 999 of them are at an MPI barrier, and one of them is off here stuck in this subroutine, right? So that would kind of be the smoking gun of what's going on. And that one core dumped, right? So he core dumped and he didn't make it to the barrier. So that's what's going on. This all happens when your program fails. But what happens if it's stuck? So in the case where it's stuck, you think, oh, this thing should only run in 5 minutes, but it just seems to be running and running and running, and I don't know what it's doing. So what you can do is you can connect to it while it's running and invoke stat. It's the same program that got invoked, in the first case when the program crashed. But you can invoke it before the program crashes, or when it's still running, and it briefly interrupts your program. It takes the backtrace of all the ranks that are running, and then it lets it resume running. So the way to do that is you need to SSH onto the same mom node where your job, if this is a job script, then in your job script, you should put a hostname command, right, which will let you know which mom node that your job script is running on. That's a good idea in general, just for for all your jobs, to just print that out because it's useful. It's useful info when things go wrong. So you find out in your job script, you put a host name. We only have a couple of mom nodes, so you're only going to see, I think there are only 2 or 3 that are actually in use, so you'll see one of those. And then before you run, if you're having these, you're expecting problems, you want to unload the module called exalt. Now, what is exalt? It's not. Exalt is something that does some very lightweight performance collection about your job when it runs, and the side effect of this, normally the side effect of this is nothing to you, essentially. But in this case where we're trying to get the process ID of the app run to connect stat to take the snapshot, the problem is that exalt wraps the app run with another process, and it obfuscates what's going on so that stat won't know where to connect. So we just need to disable exalt before we attempt to do this connection thing. So other than that, you just need to do these 2 things in your job script. Then during your run, when you think it's stuck, you SSH to that same, right? You look in your job script, your job output, right? And you'll see the host name of the mom node that your job is running on. So then you manually go SSH from the login node to that same mom node, okay? And you're logged in there. You'll be allowed to connect to that. Then do a PS to find out the process name and look for the app run command that belongs to you, that's part of that job. Then you need to do a module load stat and then invoke statcl on that process ID of the app run. That's it. You're just pointing it here. Do the app run. Look for do a PS and find your app run. Then do a statcl on that app run. And just to make sure that statcl doesn't open up a graphical user interface, I've put the display equals quote, quote, blank. That's the X11 display. I'm just disabling graphical interaction with statcl. It doesn't need it to do this command, but if you don't put that, it may fail to connect back to your laptop to open up a window. But you don't need the window. So, right, some other things you could do to make this process a little bit easier is that in your job script, if you background the app run command, right, then you could actually print out what the PID of the app run is on the next line in your shell script, right? $! expands to the last backgrounded process. And then you have to do a wait so that your job script doesn't exit, because when your job script exits, even if the app run is backgrounded, it's going to kill everything. Okay? So just to summarize what we've got so far is if your job is stuck, you can use stat. And if your job crashes, you can use ATP to, and both of those will give you the merged stack backtrace. So that's sort of static debugging, right? That's just collecting data about where it was. You're not really interacting with it. Question? No. That it was running on a compute node is where it was actually running. But you don't log into a compute node to do anything. App run is the only thing that launches stuff on the compute nodes, and the app run is launched from a mom node. So no, you don't necessarily have to use interactive mode. So the ATP functionality will work in a regular batch job. It will work in an interactive node if you do that too, but it doesn't matter. And then the stat snapshot also works both ways. I mean, but you do have to do the right preparation in the job script so that later you can connect to it. You need to figure out what mom node it's running on so that while your job is running and it's stuck, you can connect to you need to be on the same mom node to launch the snapshot. It's not, so the question is, does that work with any compiler? It's not, these things are not really compiler related. It's more a case that the right things are linked in, and the module files for the Cray and the Intel compilers have that baked into it. So with the right link line, you could use it with anything. So we would just have to figure it out. If you're using something else, we could figure out what link options you would need to do it. Yeah. Yeah, so that really only is an issue for ATP because ATP is something that needs to get hooked in so it runs automatically. The stat snapshot can be done without anything linked in, right? You're pointing it at the process ID of the app run, and then it finds out from there where all the compute nodes are and gets it. So okay, so that's sort of like the core dump functionality, whether it's a snapshot or a postmortem, right? So now we'll talk a little bit about lgdb. So you probably used GDB, regular GDB on Unix systems, and so I'm not going to cover how GDB works, but essentially you run your executable GDB, right? You can interrupt it and query variables and stuff like that. lgdb is the same thing, but it's talking to all of the ranks in your job simultaneously. And you can prefix the command. So let's say you run your program under lgdb, they're all running, and then you interrupt it, and then you can say something like on rank 6, tell me instead of saying, print A, right, to get the value of A, you would say something like, on rank 6, print A, right? So you can, it's still a crude way of debugging parallel stuff, but if you have some quick and dirty little checks that you want to run or set a breakpoint on one rank only, if you're dealing with small number of ranks, this gives you the control to do that. And to learn more about how to use it, I would refer you to the Cray user guide. But my purpose here is to just tell you how you would get your job running with lgdb on our system so that you can then follow the rest if you're interested in using this tool. So it's actually pretty easy. You need to do a module load Cray lgdb. And what you do in your job script is you put these special comments to decorate right before your app run and right after your app run, whatever your app run happens to be, right? I just gave some trivial example here. But if you say cray debug start before the app run and cray debug end after the app run, then you what you do is you invoke lgdb and then you type launch, and then suppose this is 8 ranks. $A8 q sub equals job.sh and the name of your executable. It actually looks at your job script and it figures out where the app run is from those comments, and then it actually launches the thing, right? So you would do this all from inside of an interactive job. And this funky syntax with the $A8 is, encapsulating that it's 8 ranks. And so you would set that to however many ranks that you want. So, in a very GDB-like way, you can ask for a backtrace as BT. You can continue it. You can, set a breakpoint using break, print, and there's an entire man page on this. So. Essentially, start an interactive job, fix up your job.sh, and then run lgdb and launch it that way. No, this one is running on 8. That's what the $A8 specifies. The 8 is how many ranks it should run on. Okay, so I think, though, that once you see DDT, you'll probably... I would only recommend lgdb for sort of quick situations. It's probably, for sure DDT, Alinea DDT, or should I say ARM now, DDT, is a full-fledged parallel debugger with a graphical interface. And for general debugging situations, you probably would want to use that. So let me give you some tips for how to get started with that. You want to load module Forge 19.0.2 is the most recent one that we have installed, pretty recent. The key thing is that when you do a module avail, you'll see different sections of modules listed. Each bunch of modules is in a different directory path. And the section with our site installed Forge is the section that's soft environment modules, module files. It's not the one from Cray. It's this section is the one that you're interested in. So what I'm saying is don't just load module Forge without the version number. Don't load DDT. Those are going to pick up default ones that Cray distributes. We've had we're trying to get Cray to remove them from our software job, but the problem is that Cray supplies the entire programming environment as one giant blob, and they're not all, they don't customize it for us. And we have installed things and configured them properly. So for now, what you want to do is you want to use module load Forge 19.02. That will get you the correct working version. Do not just do a module load Forge, because that uses a default that isn't the right one. Okay, so when you compile your code, you're debugging. So probably you definitely want to turn on -G, and you probably want to disable optimization unless you enjoy having a challenging view of your generated code, right? Because of code reordering and things like that, it can be very dicey. So that's standard for debugging. There's a link to the online user guide for DDT here, but let me just say that these slides are the most up-to-date reference, and that we're in the process of updating the website. So I recommend using these slides as a reference and not, in general, the procedure that's listed on the web page. Okay, So how do you start up DDT? I strongly recommend installing what's called the remote client. This is a simple app that you can install on your Mac or your Windows or your Linux machine. And what it does is it creates the graphical user interface locally, and then it knows how to talk to the remote machine where the parallel program is running. And that communication is much more lightweight than the graphical interface. So the response is quite good. There's a link here. I just realized that they moved all of their downloads to the ARM site. So if that link fails, I have the new link for you, and I will update it in the slides right after the talk. So there's another thing that I recommend. If you've been using our system at all, you realize that every time you start a login, you need to generate a cryptocard sequence. And when you're debugging, that can become especially a drag. So if you have a Mac or a Linux machine, you can go into your SSH config and add these two lines to it. It's called control master and control path. And what that does is that the first time you connect to a remote machine, you'll authenticate with your crypto card, and that'll be fine. Then the second time you connect to the same machine, it will piggyback off the first connection, and you won't have to authenticate again. So, for example, when you SSH to the Theta login, right, then you start a new window and SSH there. You don't have to type a login because the first one's still there. Then if you start the debug client, that needs a log to connect with a login too. That will piggyback off of it too. So it will save you a lot of trouble every time you start up the debugger and exit it. To just if you can use this master mode. Last I knew, Windows does not support the SSH functionality that's needed for this, but I have to say I haven't had a Windows machine since XP, so I don't know if they've redone anything. You're on your own with that, but you could try it. You could put that in your SSH config and see if it works or not. It certainly wouldn't hurt anything. It's some basic a low-level issue about how sockets and so forth are supported. You have I set it globally, but you can probably set it per host as well. So as long as the first connection is active, then you can start new ones piggybacking on that. If you exit the first one and others are existing, it will just sort of hang there because it's still serving the other ones. So you can, I'm sure everything in an SSH config is, as you point out, either global or tied to a specific host. So I haven't tried it, but you probably could tie it to the host in particular. And did you have a question too? You put this on your laptop, in the SSH config on your laptop, because you're SSHing outbound from your laptop. Okay, so going back to using the remote client, I recommend using the remote client. The download and the install takes literally like 3 minutes. There's really nothing to do. On a Mac, you just take the app and drop it into the apps folder and you're done, right? But I will say, if you're having some kind of weird issue or if you're not allowed to install anything or something, you can run the debug program on the remote end and display it back to your laptop using X Windows. And so if you do that, you would, of course, need to SSH-Y or -X to create the tunnel, and the display back to your laptop will probably be pretty slow. I don't recommend it except as a last resort. So I'll just mention that if you have a Mac, right, there's an app for the Mac. If you have Windows, there's an app for Windows. If you have Linux on your laptop or your desk machine where you're working from, what you do is you download the full version of, DDT or Forge. I guess, it's been branded as Forge now. Download the full version of Forge. You don't need a license to use the remote client functionality of the Linux install. Okay, the license is on the remote end where you're actually executing, and we have, our site has the licenses to run things. So don't think that you need a license on your laptop to run the full version and use it as a remote client. Right. So when you start the remote client, it actually looks exactly like when you run locally, right? So you get the same window, and you'll see in the middle here, right, in this pull down in the middle here, it says remote launch, and initially you wouldn't have anything filled in there, but this list is all of the hosts that I've configured on how to connect to. And if you just select configure, you end up at a window like this where you put in the host name. So you'd put your username at theta.alcf.anl.gov, and then you'd put in the remote install directory, you'd put soft debuggers DDT, or soft debuggers Forge will also work. They both point to the same place. And then you'd click test remote launch. Now, if you click test remote launch and you were not using normally you would then be prompted to do a login because it's doing an SSH to the thing. But if you did that SSH master thing, then it will just go ahead and do the test. So if that test is successful, then you say OK, and that machine will now appear in your list. And when you select it, it will connect to the machine. And when it connects to the remote machine, the Theta login, down in this corner here in the left, it will, after a few seconds, it will say license serial number something or other. And if you push the question mark, it'll give you a little more info about it. And that's a sign that everything is good, that it connected, and the piece of it that's on the login node is talking to the license server, and you're all good and ready to run. So how do you actually debug something? What I recommend is to do what's called a reverse connect. So you have the debug app connected and already on your laptop, and you just leave it there. Don't click the run thing. That's the normal, the normal connection as opposed to the reverse. So what you do for the reverse is that inside you're going to be debugging, right? So you should start an interactive job. Remember back to the beginning of the talk, start your interactive job. And then you would normally do an app run, right? So instead of doing the app run, prefix that line with soft debuggers forge bin DDT -- connect, and then app run. And the rest of the app run line exactly the way you're doing it now. Right? So just prefix this stuff, then run it. Then do that command. And what happens is when that starts up, the wrapper here of DDT will look in your file system, right? When your remote client connected, it left a little cookie or something in your home directory. And this will find it, and it will know how automatically. It's like magic. When this runs, what will happen is it will, I don't have a picture of that. It will just pop up a little window saying, hey, this parallel program is running and wants to connect. Should I let it? And you'll say, yeah, that's me, right? So you just click OK. And then you'll be connected, and you can proceed with your debugging session the same way you would, with any DDT session, right? And once again, that using DDT, it's fairly straightforward, but it's beyond the scope of this talk. And I'll be happy to walk you through it if you've never used it before. So let me just mention that while we're talking about debugging here, the map performance profiler from Alinea ARM starts up exactly the same way from that same interface. It's just on the left-hand side. Where did it go? Okay, these screenshots don't show the map button, but you select map in the left margin, and then everything else is the same. And when you're wrapping the app run on your in your job script or on your interactive command line, instead of saying soft debuggers forge bin DDT, you say bin map. That's all. Starts up exactly the same way. And for DDT at least, after it's connected and you click run, you'll see a little window as the processes are launched on the compute nodes, and this little progress bar will go across until they're all connected, and then you'll get the screen. And up here, the play button is what starts execution of everything. You can browse the source here and set breakpoints by clicking in the left column on your source lines and things like that. Okay, so this is the end of this talk.